All right, so here we have a free response question about high cholesterol. So if you want to take a second and pause the video and give it a read before I go ahead and dive into it, right now is the time to do it. So here we go. This is what's happening. We have a random selection of 20 males. Now, they took 10 and they randomly assigned them to group A, and then they took the other 10 and I guess they were randomly assigned to group B as well. Okay. After 3 months post-treatment cholesterol. So one thing about random assignment is that now that we have random assignment to two separate groups, this is actually an experiment now. So with this, we can claim cause and effect, and we're going to take that into consideration when we're writing our conclusion statements. Okay. So basically, they were given a set of instructions, and they looked at their reduction in cholesterol, whether they were given a placebo or the cholesterol drug. These are two completely different samples. Okay, so this is definitely going to be a two-sample t-test. So let's go ahead and set up our test, okay? So one, we have a null hypothesis. What we're looking at cholesterol reduction. And we're also checking to see, is it effective in producing a reduction? So we want to see if the treatment group has a greater reduction than the placebo group. So the average of the drug group is the same as the average of the placebo group. The alternate, we're looking to see if the mean reduction in the drug group is greater than the mean in the placebo group. So the average cholesterol reduction is greater in the drug group than the placebo group. All right, there's our P and H of phantoms. Okay, assumptions and conditions. So we have our drug group and we have our placebo group. All right, now drug group. So they were randomly assigned to the drug group. They were randomly selected out of the 20 and assigned. All right, it's the same thing with the placebo group. All right. It was a sample of 20 that was taken. So we're going to do 20 times 10. So this is a greater than 200 cholesterol patients. All right, same thing for placebo. As far as normality, there is nothing in the question about normality. Also, both sample sizes are not going to be greater than 30. So we have to look at the normal plot. So here's what we're going to do. We're going to go into our calculator, stat edit. We're going to go into list one. And we're going to punch in. So I always want to put the larger values in list one. In this case, we're checking to see if the cholesterol group has a larger mean reduction. So we'll put the cholesterol group into list one, or not the cholesterol group, the drug group into list one. And then for list two, we got 2, 19, 8, 4, 8, 17, 7, 24, and 1. All right. So we have our information put into list one and list two. We have to look at both normal plots separately to make sure that we're going to be okay here. So first, I'm going to look at the normal plot in list one. Looks pretty solid. Now we're going to look at list two. So we go to our data list and we just swap it to list two, push second two. And now the normal plot will be list two instead. Also looks pretty good. So we can put normal plot looks linear. And we're all set. The name of this is going to be a two-sample t-test for means. All right. So we've named the test. Now we're getting into test statistic and that kind of fun stuff. Okay. So our test statistic, it's going to be the average of the drug group minus the average of the placebo group divided by, so we need our standard deviation. If we hop over to our formula sheet, we're checking for two populations. So we roll over to here. It's this one right here. So it's going to be the square root of standard deviation of the drug group squared over sample size for the drug group plus standard deviation of the placebo group squared over sample size for the placebo group. And now we go to our calculator. Stat test. This is a 2 sample t-test. We actually have the data in there already. List 1, list 2. I want to see if our list 1 is greater. So I'm going to keep this the way it is. Run it. T-score of 1.62, round it off. All right. Our degrees of freedom that's given to us here is 17.3 and a p-value of 0.06. All right. Our alpha level is 0.01. So once again, here's what happens. Mean of the drug minus the mean of placebo. It is assumed that this difference right here is 0. Okay. When we subtracted the two away from each other, subtracted the two averages away, it came out to be 6.2. All right, 6.2 is the value of this right here. Now, remember, so what the p-value gives us, it gives us this tail size right here, 6%. But because our alpha is 1%, like this would need to get further out, okay? It's not far enough away from the mean to claim that there is a statistically significant difference. All right, so since 0.06 is greater than our alpha of 0.01, we're going to actually fail to reject. This is going to drop us into our conclusion statement. So due to our t-score of 1.62, we fail to reject the null hypothesis. So we were looking at a cholesterol drug versus placebo. If the cholesterol drug and the placebo both decreased cholesterol the same, there is a 0.06 chance of getting these results or more extreme, which is greater than our alpha of 0.01. There is not enough evidence. Now remember, this is an experiment, so we can get away with saying this next thing. There's not enough evidence to claim that the drug reduces cholesterol more than the placebo. All right, here we go.